Hey everyone, this is a quick introduction to this simulation done by the folks at the University of Colorado, I think, PhET. This is a little chance to practice launching projectiles at different angles with different speeds and different launch heights and things like that. Just play around with it and get used to looking at the various things you can do. So here's just a 65-degree angle cannon shooting at 18 meters per second. You can see it here if we fire it. I like the way they put the combination vectors. If I pause it somewhere, you can see that the horizontal component is always the same, and then the vertical component changes as it goes up and comes down. And we'll just let it keep playing. And there it is at the end. Okay, so that's the projectile going at 65 degrees. We can see that if we brought this down to 25 degrees, what would you expect it to do? So give it a shot, think about it first, and there it goes. And sure enough, it goes to the same position because of that symmetry around the 45-degree angle. That 25 degrees is 20 degrees less than 45 degrees. So 20 degrees more than 45 will give you the same destination. Okay, so you can dial it up a little bit faster if you want and see how much farther it will go. And again, if I pause it, I like the way you can see gravity is always pulling at the same strength, but the vertical component, it's still on the way up, so gravity has not yet negated that upward velocity. It will eventually peak probably about here. The combination of these two vectors you can see in the dark green. In this case, it still has the upward component. The horizontal component is going to stay the same throughout because we're neglecting air resistance. So you'll see it'll go a bit farther when we hit play. And there it is going out of the screen. Okay, so you can try different things like taking it from different heights. I can lift it up. I can shoot it horizontally, for instance. Once I get it above the horizon, I can clear this out. And you can see we've done a lot of problems where we're saying, okay, if something is fired from 5 meters off the ground, what's going to happen to it? Well, you'll see that it's in the air for no different amount of time based on the speed. If I dial it way back to like something very small, it's going to basically come out and drop on the ground. There it is. Oops! It doesn't even leave the cannon. Can you drag it over? Nope. So it's a little bit unrealistic. But if I bring the speed up a bit, you'll see that now it's going farther. But the number of little dots here, that's representing probably 1/10 of a second. If I dial that up, you're not going to have a different number of dots. They're just going to be spaced farther apart, and they should line up vertically so that this dot is opposite this one at the same level. It's after it's fallen the same amount of time. Dial it up even faster, and you'll notice that it goes farther away because it's moving faster, but the actual time it takes for this projectile to leave the cannon and go to the ground is the same, because only the vertical component is affected. And it's independent of the horizontal component. How fast it's going to the right has nothing to do with how quickly it falls. All right, so there's that one. And then on another tab, we can do this one is all about force. This is the introduction. So I can push on this. I just click on it and drag it, and I can push that box, and I can then stop it and hear the force of friction or the force of the guy pushing on it. So you can see you get the little free body diagram, and I can pull it back and forth. I think right now you can see in the upper right hand corner here, I can show the free body diagram at any one moment, so you can kind of get used to seeing what that looks like. Again, when I move it, you'll see that the free body diagram shows the forces acting on it. The yellow one is always the force normal. That N stands for normal. The one going vertically downward is the force of gravity. So those two balance out. If they weren't balanced, the box would either float up in the air or fall through the ground. But because it's not moving, they have to be balanced and equal. Then when I push on it, by just clicking on it and dragging, you can see that the person pushing, their force exceeds the force of friction. This has got wood friction, we're supposed to imagine, or ice with no friction. So if I push on it here, it's going to go a little bit even if I just push it a little bit because there's no friction. All right, so that's the introductory tab. Try one here with different amounts of friction, where again I'm just pushing on it, and you can see the free body diagram. You can get used to pushing these things around. It just helps you to kind of picture the forces that are working on something. This one is kind of fun. It's the Robot Moving Company. You've got your robot here, and you're using the left and right arrows. They give you the little indicator up in the upper right hand corner. A great big heavy file cabinet. I hold down the right hand arrow and I can push it, and then it slides over, and hopefully not too far. It hasn't quite fallen off the edge, and I can push it back, and there, whoop, and there I moved it in, okay, and it gives me points. Now I'm going to push the dog gently. Dog has less friction, I think. More friction maybe, and I'm getting the dog to go to the house. Okay, now be careful because the book is super lightweight. If I just push on it a little bit, it'll push it too far and it'll go way past and fall. Okay, so you can try to get good, see if you can get over 1,000 points. It's not easy. Gets you used to thinking about pushing things with different amounts of force. Okay, so there's a few things to play with and get started. Good luck, everybody.